Hello, ladies and gentlemen. Time for a little overview of Unit 3, Lesson 3, Function Junction. On the front here, it has 5 different functions to look at. You have to figure out which one doesn't belong. So take a moment to look at each one and figure out which one doesn't belong out of these. Well, this actually has multiple answers. You just need to pick one and be able to justify your answer. I'm going to pick D, this one up here, because it is entirely discrete. It's the only discrete function here. And it's not the only function. It's the only discrete function here. Sorry, let me put the word in there. Discrete function. All right, all the other ones are continuous, well, except for point of discontinuity there. But yeah, so that's what's going on in front. There's a little reason there. And then we can get into the rest of the task here. What's going on in the function junction is you're given functions of varying formats. Some of them are tables, some of them are graphs, and some of them just give you an equation and you have to graph it yourself. And then it's asking you for different properties of that function, such as domain and range with the maximum mins, what are the intercepts are, the intervals that increase and decrease, things like that. And so we're going to just look at a couple of these to help you get started on it. This first one here, you should read the words. It does matter. The table represents a discrete function defined on the interval from 1 to 5. It's discrete. That means it's the individual points, not a continuous one like the other ones in our first example there. So I'm looking at this. It goes 5 and then 10 and 40 and 80 and 60. Looks like here it doubled and here it times by 4 and here it times by 2 and here it times by 2. So this one's not strictly linear or exponential, but it is increasing here. So when I list my domain, that's going to be these values. And what makes this answer a little bit different than normal, instead of just writing 1 to 5 like that, is this one is discrete. And so when you use an interval like this, it includes all the in-between values as well. This one does not include in-between values, so I'm going to just be writing out each number individually. 4, 5. And I'm going to put a little bit different brackets on it. Instead of just like the parenthesis or the square brackets on it, I'm going to use these squiggle brackets, and that lets you know it's just those individual numbers, not the ones in between. The range here is a similar vein. It's just 5, 10, 40, 80, and then the 160, since we just have those individual values. The maximum on this is just, remember when you're looking for maximum, you're looking for the highest function value, which is going to be this 160 in this case. So the maximum is at 5, 160 at that point. And the minimum is just the lowest y value, so that's when n is 1. So you got 1 and 5. The intercepts, that's going to be when your x is 0 and when your y is 0. Right, hits the y-axis, hits the x-axis. Since this one is strictly defined on this interval, it actually doesn't have any intercepts, because it never actually reaches 0 in either the n or the f of n. So is that the interval of increase? You have to think about if you were to graph this, you got 1, 5, 10, 40, 80, 160. All right, this one just goes up really fast. It is increasing the entire time, so it's going to be increasing from 1 to 5, which is this entire interval. And then the intervals of decrease, since it's only increasing, it doesn't have any decreasing. So you could put none or NA, something like that. And so yeah, there's kind of an example there. This one's a little bit different because it's discrete, which is why I wanted to go over it with you. On a lot of the other ones we've been looking at, we have intervals and they're all continuous, and so you're going to use intervals to describe domain and range and things like that, unlike this one, which is just the individual values. Let's look at one more example, one where you have to do a little bit more work on it. Let's go to 3. We got this function g of x equals 3 to the x power. We need to graph it and then determine key features. So let's do the graphing part. Let's add some axes here. And since I know it's 3 to the x power, I know it's exponential and it's going to get really big really fast. And when I look at my function, I notice my initial value is going to be 1. And because this 3 here is the growth factor. And so I'm going to have a y-intercept of 1. and it's going to times by 3 each time I go to the right. So it's going to go up to 3, and it's going to go up to 9. Here, 4, 5, 6, 8, 9. So it's going to go up to here, and then it goes up to 27. So it's going to go up really fast. On the left side, it's dividing by 3, which means it's getting smaller and smaller and smaller. So it's almost horizontal over here, but then it shoots up really fast, because that's how exponentials work. So here's a graph of our function. We need to get its domain and range, the minimum, maximum, intercepts, all that stuff. Remember, domain is the x values, is how far it goes left and right. It does go left forever and right forever. So it's from negative infinity to positive infinity. The range on this one, you have to think of how far down it goes, how far up does it go. Well, this function gets closer and closer and closer and closer to this line here, which is at 0. So that's our smallest number, 0. And it goes up from there. It continues to go up and up and up and up forever. So we got 0 to infinity. The maximum here, on here it looks like we have a maximum, but it does have this arrow. It goes up continuously. It never stops going up. So we don't actually have a maximum. So we can put NA or none. Same with the minimum. We never actually reach the smallest point on this function. You can think you find the smallest point, and then there's one smaller than it. So we never actually quite reach one. The intercepts, since this doesn't hit my x-axis, it doesn't have an x-intercept, but does have a y-intercept, because it hits my y-axis right there, which happens to be at 0, 1. Just that point right there on our y-axis. The intervals of increase. So on this one, as you travel from left to right, it is increasing. And you can see that over here. Over in this section, we just talked about, it gets closer and closer and closer as you travel left to the x-axis. So as you're going to the right, it's getting farther and farther and farther away from the x-axis. And it lets you know, like even over here where it looks pretty flat, it is increasing. It's just increasing really slowly. So our interval of increase is negative infinity to positive infinity. The interval of decrease then is going to be none or NA, because it doesn't ever decrease as you go left to right. So that's a lot of what's going on. Sometimes you have to graph the function, sometimes you're given a table, sometimes you're given a picture. There's a lot of different things. Yeah, and by the way, you can have more than one interval where it's increasing or decreasing. For instance, on this one, we have an interval where it's decreasing here, and then it's also decreasing in this section here. So you can write out two different intervals. In this case, it goes from 0 to 6. Got my interval there. And then when you get another one, you put a U, and it goes from here, which looks like 7, until you hit here, which looks like 18. So you got 7, 18, and you have two different intervals. So it's okay to have more than one interval. Just make sure you put a U there to denote that both of them are included in the answer. But let's get past that section there. Let's jump to the retrieval part. In the retrieval part, you need to complete some tables. And when it means complete the tables, like here are some X's, what are the Y values that go with them? So you're just filling in the blanks there. If you're not quite sure, what you can do is you can just put the number in the function. So you got negative 2 times 0 minus 5. That gives you negative 5. And so that's going to go there. And then you can plug in a 1. So you got negative 2 times 1 minus 5 gives you negative 7. And you can fill it in. You can keep plugging each of those in. Or you can use the fact that you know something about how functions work. This is a linear function. The y-intercept's negative 5 and the slope's negative 2. And so in my table, I start at negative 5 when x is 0. And then it's just going down by 2 each time. Down 2, down 2, down 2. So we got negative 9, negative 11, and negative 13. So that's what's going on filling in the tables. And you'll just fill in the tables. At the end, you write your recursive and explicit functions like we've been doing with sequences for quite a while now. So that's your overview for lesson 3, function junction.